Okay, guys, so we are going to solve some exercises about the Pythagorean theorem that you saw in one previous exam. So first, we have these two exercises in which we have to determine the missing side. In this case is this one. I am just going to call it x, and in this way, in this one is this side, which let's also call it x. Okay, let's not use the question mark. Let's call it x in both sides. So here, this is the hypotenuse. So remember that the Pythagorean theorem says that the hypotenuse squared is equal to the two legs squared added. So 12 squared plus 9 squared. Okay, so that means that x squared is 12 multiplied by 12, which is 144, plus 9 multiplied by 9, which is 81. Okay, that, if you add it, you get, okay, let's see what is 144 plus 81. 4 plus 1 is 5, 4 plus 8 is 12, and 1 plus 1 is 2. So basically, it's 225. Sorry, the root not yet. X squared is 225, and x, for that you have to find the square root of this, 225. Okay, so you can either do it with the calculator, and you will get a quick answer, which is 15. But let's actually remember how to do it by hand, because remember, if the result of the if the result of this is a whole number, a natural number, you can get it by prime factorization. Let's do it. And remember, we start dividing this number by the prime numbers, which are 2, 3, 5, 7, 11, 13, 17, 19, and so on, but usually you don't need more than that. 225 can be divided by 2. Yes or no? In this case, no, it's not an even number. Can it be divided by 3? Let's check. Remember, in order to check if a number is divisible by 3, what you do is adding the digits. So 5 plus 2 plus 2, it's 9. And since 9 is multiple of 3, so it means that this one can be divided by 3. So let's remember how to divide. 225 divided by 3. So 3 does not fit in 2, but it fits in 22. It fits 7 times. 7 times 3 is 21. You subtract, you get 1. You drop down the 5, and 3 fits in 15 5 times exactly. So this is 15, 0. Yeah, we did it. Okay, so the result is 75. Oh, wait. Okay, can it be divided by 3? Again, like, let's see. 5 plus 7, it is 12. Yes, it can be. 75 divided by 3. Let's do it again. 3 fits in 7 twice. 2 times 3 is 6. And then you subtract it, you get 1. You drop down the 5, and it fits exactly 5 times. So it's 25. Yep, let me erase this. Yeah, and 25 cannot be divided by 3 anymore. So, well, the 2 didn't work from the beginning. The 3 now doesn't work anymore. So let's try with 5. and it can be divided by 5. The result is 5. This one can still be divided by 5, and the result is 1. So this is the prime factorization. Now, what does it mean? That square root of 225 is a square root of 3 multiplied by 3 multiplied by 5 multiplied by 5. Yeah, that means that this is the square root of 3 squared times 5 squared, because 3 times 3 is 3 squared, and 5 times 5 is 5 squared. And then we can split the root. And this cancels. So it's just 5 times 3, which is 15. Yeah, it's a quite long process, but if the root is a natural number, you can get it by doing this. If you forgot how to do that, please check in ManageBack, or actually in this channel, the video about prime factorization and simplifying roots. So the result is 15. Sorry, I'm going to erase everything. So this is 15. Now, let's move over to this one. For this one, I am not going to do the whole thing. So here we have the hypotenuse. So 65 squared is supposed to be the addition of this squared plus this squared. So 25 squared plus x squared. So 65 squared, let's actually now use the calculator. 65 times 65 is 4,225. 25 squared is 625, and this is still x squared. Okay, how do we get this? Just subtract these two numbers, okay? Remember, when you have the hypotenuse, instead of adding, what you actually do is subtracting. So 4,225 minus 625. Yeah? And let's actually do it again. That's 3,600 is x squared. Now I'm going to continue here. I didn't have enough space. So x is the square root of that. And the square root of that, if we do it with calculator or with the other method, you will get that it's 60. So x is 60 in this case. Yeah, basically that's the two cases that you can get in a Pythagorean theorem exercise. Either you don't have the hypotenuse or you have the hypotenuse. If you have it, if you don't have the hypotenuse, like make the two other numbers squared and add them, like we did here, and then find the square root of that. If you have the hypotenuse, then make the other two numbers squared, subtract them, and find the square root of that. It can be summarized like that. Now let's move to this one, okay? Here we are asked to determine whether the triangle using these measures has a right angle, okay? So basically, if it's something like this, okay, if we can with this measure create a right angle triangle. So a few things to take into account in this case, okay? If this were a right angle triangle, the longer side would be the hypotenuse. So which one of these three is the longest? It's 27, so this will be the hypotenuse. Yeah, so the 27 should be here. Excuse me, 27, not 25. 27 centimeters. And any in any order, the 14 and the 20 and the 21 would be the legs. So 14 centimeters and 21 centimeters. So what happens? If this were a right angle triangle, you could do the Pythagorean theorem and it should be perfect. I mean, if you do 14 squared plus 21 squared, that should be equal to 27 squared. Okay, so let's do it. Let's continue and see if this is true or not. So what's 27 squared? 27 times 27, which is 729. Okay, now what is 14 squared? 14 times 14, 196. What is 21 squared? 21 times 21, 441. Okay, so actually let me write this properly. Okay, so if this addition is 729, that means that yes, this can be a right angle triangle, but let's do it and you will see that not. Okay, 196 plus 441. That's 737. Sorry. Wait. Let me do it again because I lost it. Yeah, 637. Is 637 equal to 729? No. So this is not a right angle triangle. Sorry. Yeah, that's how you solve this one. If you want to check if these measures account for a right angle triangle, do the Pythagorean theorem with them, and if the result is the same than the hypotenuse squared, then yes. If not, like in this case, then it's not a right triangle. Okay, about the word problem that you had to solve during your exam. Okay, so we have some information. You are planning a hike starting from point S. So we begin here, and that's why it's really important to always read the information that is given to you and actually understand what you are being asked, not just check the numbers and the figures. Actually read. If you have some information reading, it's because it's important. So you start here, and your hiking club has identified two potential campsites, so A and B. So these are potential sites that you can make a camping after hiking. So this is other important information. The distance from S to A, so look at it. I am going to put it in colors. From S to A, I am going to use red. So from S to A is 500 meters. The distance from S to D, so look at it, I am going to put it in blue, S to D, and I am going to make it a little like wide so it doesn't get lost. That is from S to D is 300 meters. Okay, and the distance from B to D, I'm going to do it in maybe yellow or green. No, yellow. That is wait, I was pressing the wrong button. That one is 400 meters. So you have to do two things. Using the Pythagorean theorem, you have to calculate the distance from the starting point, which is S again, to each campsite, which are A and B. So you already have one. I already gave you. From S to A is 500, but we have to find from S to B. Okay, we are going to do it in a moment. And then we have to state which campsite, which of these two, is more convenient by taking into account the total hiking distance and the total altitude of both campsites. So you have to take into account these two things. Look, hiking distance and altitude. So your conclusion has to be about these two things. Okay, so let's actually do it. Let's actually find from S to B. And I am going to redraw that triangle like SDV here. Okay, I am going to use the same color so you don't get lost. Yeah, like this. So this is S, B, D. This is 300 meters. This is 400 meters. And this is X, or whatever variable you want to call it. Let's find it. And since this is a right angle triangle and this is the hypotenuse, x squared is going to be 300 squared plus 400 squared. Okay, what is 300 squared? If you do the multiplication, you will get that it's 90,000. And here, if you make 400 squared, it will be 160,000. That should be x squared. Okay, if you add these two things, what do you get? You get 250,000. That's x squared. Okay, and remember, we still need to do the square root of that. So if you do it either by prime factorization or with the calculator, you will find that it's 500. So this is 500 meters. Okay, so we found that actually both distances are the same. In order to get from the starting point to each one of the campsites, you take the same distance. Okay, but remember that for this item, you have to take into account hiking distance, which is the same, so maybe it's equally convenient, but also altitude. So which one is higher? Okay, and which one is higher? Wait one moment. Yeah, which one is higher? This one is higher. From S to B is higher than from S to A. Yeah, it's the same hiking distance, but one is more inclined than the other. So you can either say that A is more convenient because you take the same distance, but you hike less, so you don't get so tired. Or if you think about the opposite perspective, if you like hiking and you want to hike more, a more difficult hike, then B is more convenient because even if it's the same distance, you will be hiking harder. So maybe that's more convenient for you, but what matters is that you have to explain it. Okay, give proper reasons to which one is more convenient, taking into account these two things. So please always read what you are being asked. Okay, so that's it. B to D, distance from 100 meter, S to D, 300 meters, S, A to C. Yeah, yeah, yeah. I was missing one distance. Sorry. And we will need it for the next point. I was missing this. Yeah, I was missing from A to C is also 300 meters. Okay. Sorry about that, because we will need it here. Okay, let me put it again here. This one is 300. What colors did I use? Yellow. This one is 400 meters. I also used the red one. Oh, wait, 500 meters. I also used the blue one. .300 meters. Okay, your hiking club wants to know the total distance from A to B. Okay, from here to here. Okay, let's think about it for a moment. How can we do it? Well, I am going to, which color should I use? I am going to do it with red but pointed, okay? Okay, so in order to find this distance, what we can do is create an imaginary right angle triangle. Look at this one. Imagine that you make a perpendicular line here and form a right angle, and you are thinking about this small triangle between these two. Well, yeah, between these two. So actually, let me draw it properly apart. I am going to make it a little bigger. Okay, wait. Okay, so this one. So this is going to be B, this is going to be A, but what or how can we do it? Because if we can apply the Pythagorean theorem, we can find this hypotenuse. Okay, do we know this distance? Actually, yes, because look, this big distance is 400, and this small distance is 300. And from here it's also the same, no? If this is 300, this is also 300. So 400 minus 300 is 100. So this is 100. And what happens here? What happens with this one? This distance is the same than here, no? Well, actually, if we know that this is 300, and if we find the whole distance from S to C, we would be able to find a distance just subtracting S to C minus S to D. But in order to do that, we need to make again a Pythagorean theorem. Look, I'm going to draw this triangle apart. This is SCA. I'm drawing this triangle. We know that this is 500. We know that this is 300. And we have the hypotenuse. So 500 squared is, let's find this, x squared plus 300 squared. But we can find x squared by subtracting these two. 500 squared minus 300 squared, because if we have the hypotenuse, what we do is subtracting. So basically, x squared is, what is this? 250,000 minus 90,000. Yeah. And x squared is 160,000. And if we do the square root of that, 160,000, this is 0, we will find that it's 400. Yeah, x is 400. So this whole distance is 400 meters. So what is the red one that we wanted? It's 400 meters minus 300, which is 100. So this distance from D to C is 100. Therefore, this one is also 100. And now we can do the Pythagorean theorem. Okay? X squared equals 100 squared plus 100 squared. So x squared is 10,000 plus 10,000. Sorry. Yeah, so x squared is 20,000. And if we do the square root of that, excuse me, we will get that this is approximately, and this one is not a natural number, so we got it with the calculator. It's 141.4 meters approximately. So the distance from A to B is 141 meters, 0.4. Yeah, actually, let's confirm. I don't remember if that's the exact value, but we can confirm with the calculator right now. So basically, square root of 20,000. Wait, no, a square root of that. Yeah, 141.4213, all of that. So that's how you solve this point. If you know Pythagorean theorem and you want to find the distance between 2 points, maybe if you create an imaginary right angle triangle, and if you find the measures, you can find that distance. That's going to be it for this video.